Okay, problem 15. So we have this circle O and the PA, PB are tangent to circle O at AB. Then PEC are on the same line, EC are on the circle. We know that PE equals 2 and DC equals 1. So we want to find the length of DE. So let's set DE as length X. Okay. Right. We have some pairs of similar triangles, so we can use the proportions of the side lengths to solve the problem. For example, we have triangle PAE similar to triangle PCA. Okay, and this means we have AE over AC equals AP over CP and equals EP over AP. Okay. Also, on the right part, we have triangle BEP similar to triangle CBP. This implies BE over BC equals BP over CP. But we know that AP must equal to BP, okay? Because they are tangent line from the same point P, so they are equal. And so this AP equals BP. And so these two equations, these two are equal, okay? We can put equation along all these 5 ratios, okay? And then we have the following. So we can calculate the area of triangle. Okay, let's do this. The area of triangle AEB over the area of triangle ACB. So the area of triangle AEB is 1/2 AE times BE times sine angle AEB. Okay, over 1/2 AC times BC times sine angle ACB. Okay, and then we can cancel a lot of terms because here we have angle AEB plus angle ACB equals 180 degree. That means they have the same sine value. ACB. And then we'll also cancel this 1/2. So this ratio actually equals AE times BE over AC times BC. Okay. So this equals to the product of two quotients, AE over AC times BE over BC. So AE over AC is the first line. So it equals AP over CP. BE over BC is actually the second line. It also equals EP times AP. Okay, and this equals EP times CP. So EP times CP is basically 2 over 3 plus X. Okay, that's the ratio of these two triangles area. On the other hand, we can consider these two triangles as that they share the same base AB. Okay, they share the same base AB, and the height the height is proportional. The height of triangle, okay, let's do this. If I can draw a height here, maybe here. So suppose H. I can also draw the height here, this capital H maybe. So H over capital H will be equal to X over 1. Okay, will be X over 1. So if I mark this as if I mark this as X, this as Y, so we have similar triangle, right? EXD is similar to triangle CYD. So the ratio of the height is equal to the ratio of this hypotenuse, ED over DX, which is X over 1. So that's also the ratio of these two areas. So this equals X over 1. And now we get the equation of X. So X over 1 equals 2 over 3 plus X. This implies X squared plus 3X minus 2 equals 0. And now we can solve the value of X. Of course, in general, we have two roots. But here, X is the side length. It is the length of the line segment. It must be positive. So here I have to put a positive sign. Square root of 17. Okay, 9 squared plus 8. Sorry, 3 squared is 9. 9 plus 8, 17. So X positive. So that means M plus N plus K is equal to 17 plus 3 plus 2. So the answer is 22. Okay, the answer is D. Okay, let's do problem 16. We have the following function in terms of this integer part of certain expression. We need to find the capital N, the number of possible values for f, if x ranges from 0 to 100. All right, let's see. For this function, we only have these jumps for different values. So let's see how many jumps do we have when x ranges from 0 to 100. So let's analyze each part. For example, for the first part, integer of x, this function jumps if x changes by 1. Okay, when x at 1 or minus 1, the value jumps. Okay, for every 1. And then for 2x, this function jumps if x changes by 1/2. Because if we exchange 1/2, 2x changes by 1. So the value jumps. And also for 5x over 3, this function, if the value changes by 1, the total value changes by 1. So when x changes by 3 over 5, 5x over 3 changes by 1. And then we have 3x. This value jumps if x changes by 1/3. And lastly, we have 4x. When x changes by 1/4, the value changes by 1. Okay. So now let me draw some picture to show this possible point makes this value jumps. Okay. So here we consider that the small interval from 0 to 3, because 3 is a common multiple of these numbers. Okay, these numbers 1, 1/2, 3 over 5, 1/3, 1 over 4. 3 is a common multiple of these numbers. Okay. Now let's start from 0 to 1. Okay, to 3. 3 is open. Okay, let's do this is 1, this is 2, 3. 3 is not included. So for the first part, we know the value jumps at these integer points. See, at 1, okay, at 0, at 1, at 2. It jumps 3 times on this interval, okay? And next, we consider 2x. So this part jumps for every 1/2. So we have this 0, and this 1/2, 1, sorry, 1/2, 1, and this 3/2, 2, 5/2. Okay. So in the first part, we have three points here. And in the next part, let's just count this new point. Okay, we add 3 more points. That's 1/2, 3/2, and 5/2. Okay. Next, let's do 5x over 3. Okay, here should be 3. 3. 1, 2, 0 here. So a multiple of 3/5, right? So here we have the following points. It's 0 here, and 3 over 5 here, and 6 over 5. 6 over 5, and the next 9 over 5, and 12 over 5. 12 over 5. We have 4 new numbers, so we add 4 in this part. Okay, we don't count old numbers anymore. Now 1/3, a multiple of 1/3. 0, 1, 2. Okay, now let's count what's new numbers here. So first we have 1/3. Okay, we're 0, but 0 is already counted. Now we have 1/3, which is new, and 2/3 is also new, and 1 is old, is already counted, and then 4 over 3, this is new, and 5 over 3, this is also new. 2 is just old. Then 6 over 3 is just 2. So we have 7 over 3 here. Let me write 7 over 3 and 8 over 3. So these are new numbers. We have 6 new numbers. So we add 6 here. Okay. And then we will consider 1/4. 1/4. So 0, of course, is old. 0 is old, and then we have 1/4, which is new, and the 2/4 is just 1/2. It's already counted. So 1 over 2. 3/4 is new, and 1 is already counted. 5 over 4 is already counted. Oh, sorry, 5 over 4 is new, but 6 over 4, which is 3 over 2, is counted. And then 7 over 4 is new. And then 2 is old. 9 over 4 is new. 10 over 4, which is 5 over 2, that's old. 11 over 4, that's new. So we have these numbers are new. They are purely a multiple of 1/4, which is not a multiple of 1/2. So totally we have 6 new points. Okay. Now if we count the total jumps over the interval from 0 to 3, we have the sum of these 5 numbers, which is 22, okay, which is 22. 6 plus 10, yeah, 22. That means for the interval from 0 to 3, 3 open, we have 22 values. Now, let's consider the interval from 0 to 100. So 100 equals 3 times 33 plus 1. So we've considered the interval from 0 to 99. On the interval from 0 to 99 open, there are 22 times 33 values, which is 726 values. And then we should add this new values in the last interval from 99 to 100. Okay, let's see how many new numbers are on the interval from 99 to 100. So, but it's close on both parts. So if it's 99 and 100, so let's consider this point. In each case, so actually we can just consider like the interval from 0 to 1 inclusive, and see how many points do we have. Let's just do interval from 0 to 1. 0 to 1. Okay, first we count integer parts. For integer numbers, we have 2. Okay, here we have 2 integer parts, 0 and 1, because we need to consider both endpoints. So we have 2 numbers, and then we consider 1/2. This is 2. So here we have only 1 point that's new, so it's plus 1, and then we consider 3/5. Okay, so we have 3/5 here. That's new, 0. That's just old, so plus 1. And now we'll consider 1/3. 0, 1/3, 2/3, and 1. So we have 2 new numbers. And lastly, we have 0, 1/4, 1/2, and 3/4. So we have these 2 new numbers. So we just have 2 new numbers. Here we have 8. We have 8 new numbers. Right. Now, the total possible values from 0 to 100 is is 726 plus 8, which is 734. So this number is the n in our problem. But in our problem, we need to calculate the sum of digits of n. Sum of the digit of n equals 7 plus 3 plus 4, which is 14. So the answer is 14. All right, problem 17. So 2 people play ping pong. For each round, the winner gets 1 point, and the loser gets 0 points. If one person gets 2 more points than the other, this people with more points will win, and the game will stop. Or if the total number of rounds played is 6, the game stops. So we need to find the expected number of rounds when the game stops. Okay. So let n be the number of rounds played when the game stops. Okay. So That means the total number of points for these two players equals n. Each time one person gets 1 point, the other gets 0. Okay. So there are two types of cases. First one, if n is just 6, okay, that's possible. But when the game played is just 6 rounds, we stop the game. Or n is less than 6. That if n is less than 6, we are sure that one person wins. So the loser gets k point, and the winner, okay, the winner of the whole game gets k plus 2 points. So the total number is n equals k plus 2, which is 2k plus 2. So in this case, we have n equals 2 if k equals 0, or n equals 4 if k is 1. So we have 3 possible values for n, 2, 4, 6. Now let's calculate the probability for each of this number of rounds. So let me try to draw a table here. So number of rounds, and the second column, let me write as the probability. The third part, let me write contribution to the expectation. To the expectation. Okay. So for the number of rounds, we have 2, 4, and 6. Now let's consider 2. If n equals 2, what's the probability? Okay, we only played 2 rounds, one person wins. There are only 2 cases. Either William wins, okay? Let me use this notation. If I use W, means William wins the game. If I use L, means Leo wins the game. So we have either William wins the game or Leo wins the game. There are 2 cases. If William wins the game, that means William wins 2 rounds consecutively. The probability is 1 over 3 square, which is 1 over 9. If Leo wins the game, that means we have LL, so it's 2 over 3 square, which is 4 over 9. Okay, the probability is the sum of these 2 numbers. And here, let's count the contribution to the expectation. So probability is 1 over 9 plus 4 over 9, which is 5 over 9. And then to calculate the expectation, we should multiply the probability by this number, 2. 2 times this probability. So this equals 10 over 9. This is the contribution of this case to the whole expectation, right? Next, let's consider the number of rounds to be 4. Okay, number of rounds to be 4, that means the winner gets 3 points and the loser gets 1 point. So we have either William wins. If William wins, we have 3 W's and 1 L. So there are 2 cases. William, Leo, William, William. So in this case, we have 2 over 3 times 1 over 3 cube. This equals 2 over 81. And also, or we have L, W, W, W. So in this case, we also have 2 over 3 times 1 over 3 cube, which is 2 over 81. We cannot have the first 3 to be W, because that means we cannot have William win from first round to the third round, because if he wins 2 rounds, he already wins. So we cannot have 3 wins rounds for William to win from the 1 to 3. So we will just have these 2 cases. Right, next, let's consider that Leo wins. If Leo wins, we have the following cases: L, W, L, L. So here we have 1/3 times 2/3 cubed, which is 8/81. And or we have W, L, L, L. This case also corresponds to that Leo wins. So it's also 1/3 times 2/3 cubed, which is 8/81. Okay, and now let's calculate the total probability. The total probability is 2/81 plus 2/81 plus 8/81 plus 8/81. Okay, this is the probability that the total number of rounds played is equal to 4. And then the contribution of this case to the whole expectation is 4 times this probability. So this equals 80/81. Okay. And finally, we need to consider the case that the total number of rounds played is 6. Okay, 6 is a little bit complicated, but we don't need to worry about these detailed cases, because the total probability is 1. So this probability is 1 minus the previous probabilities. So the previous probabilities will be 5/9, and this is 20/81. So this probability is equal to 16/81. Okay. And then we calculate the contribution of the expectation to the whole expectation in this case. So it's 6 times 16/81, which is 96/81. Okay. So to calculate the whole expectation, we just add these numbers. Is 10/9 plus 80/81 plus 96/81. This value is equal to 200. Okay, let me use common denominator. This 81/90 plus 81/80 plus 96/81. So 266/81. Okay, that's the answer. So we choose C. Okay, we choose C. All right, let's do problem 18. Right, we have this unique unit cube ABCD A1 B1 C1 D1. So here M is the midpoint of CC1, N is the midpoint of A1 D1, O is the center of the base ABCD. We need to find the volume of the tetrahedron OMNB1. So the idea here is to divide this tetrahedron into 2 smaller tetrahedrons. All right, let me call the midpoint of B1M to be P, okay? Let me call this point to be P. And the midpoint of B1, C1 to be, say, X. And the midpoint of BC to be Y. Midpoint of AD to be Z. So basically the idea is to cut this whole solid by the plane passing through N, X, PY, Z, N. we use this plane to cut everything, okay? To cut everything. So this divides this tetrahedron into two smaller tetrahedron. All right, let's look at this plane. This plane is parallel to the plane A1, B1, AB. So let me draw this plane. This is N, this is X, and this is Y, and this is Z. Okay, this is a 1/1 square. And so because X is the midpoint of B1, C1, and XP is parallel to C1M, so P is the midpoint of B1M. So it implies P is the midpoint of B1M. Okay, and we see that Px is 1/2 of C1M, but C1M is 1/2 of C1C. So this equals 1/4. So this midpoint, P is here. So we consider triangle NP. Okay, O is the midpoint of YZ. Is O. Let's consider PNO. Okay. So if we draw it in the figure, this corresponds to the base of two tetrahedron. Triangle PON is the base of tetrahedron M PON and B1 PON. Okay, so let's calculate the area of this base. So XP is 1/4, and the PY is 3/4. YO is 1/2. OZ is 1/2. So the area of triangle PON is the area of the whole square minus 3 smaller right triangles. So the area of triangle PON is 1 minus the area of triangle PXN minus the area of triangle PYO minus the area of triangle OZN. This is equal to 1/2 minus 1/2 times, so PXN, the area is 1/4 times 1. This is 1/2 times PYO is 3/4 times 1/2 minus 1/2 times 1/2 times 1. So this is, sorry, here's 1. 1 minus 1/8 minus 3/16 minus 1/4. So the area is 7/16. Okay. So the volume of the tetrahedron OMN B1 is the volume of M PON plus the volume of B1 PON. Okay, and B1 PON and M PON have the base PON, and their heights will be XC and XB1. So this corresponds to 1/3 times the area of triangle PON times the height of MPON. So MPON, the height is XC1. Okay, the second one is 1/3 times SPON times the height. The height is B1X or XB1. Okay. Now this equals 1/3 times SPON times XC1 plus XB1. But XC1 plus XB1 equals 1. This equals 1. So this equals 1/3 of the area triangle PON, which is 7/48. So the answer is 7/48. All right, problem 19. So we have 10 sticks with lengths from 1 to 10. We need to find some of the sticks to form a square. The question is, how many different sets of the sticks will be possible to use to form a square? Okay. All right, let's first consider the possible values of the side lengths of the square. Let's call this side length A, okay? We note that the sum of these numbers, 1 plus 2 plus 3 plus 10, this equals 55. So the side length will be no more than 55 divided by 4. And of course, it's integer, so we choose integer part. This value is 13. So the side length is at most 13. Okay, now let's also see the minimum possible side length. So A is largely equal to 7. Okay, this is not hard to see because we can make the side length to be 7. So 7 is one side, and 1 plus 6, 2 plus 5, and 3 plus 4. If the side length is smaller than 7, we cannot find these sticks to form 4 such A, okay? That's impossible. It's easy to see. All right, so let's now discuss for each side length, how many cases do we have, okay? So let's start from 7. If A equal to 7, there's only one way, just above 1, okay? So 1 plus 6, and let me still copy this picture. 1, 2, 3, 4, 5, 6, 7. So 1 plus 6, 2 plus 5, 3 plus 4, and 7. So we only have one set, one case. Let me see, one case. If the side length is 7, okay? Next, if the side length is 8. If the side length is 8, let's see how many ways can we add certain numbers to number 8, okay? So the largest number we can use is 8. We don't need a number larger than 8 because we just need to have a sum equal to 8. So 8 itself is a 1/8, and 1 plus 7 is 8, 2 plus 6 is 8, 3 plus 5 is 8. And here we don't use 4. Of course, you may ask that we can use 1 plus 2 plus 5 is also equal to 8. But if we use 1 plus 2 plus 3 plus 5 as the side of this square, then we don't have enough other sides. We don't have enough 8, okay? Right, so here that means we still have just one case, okay? This is not good, okay. It is true that equals 8, but we don't have enough 8 for other side, okay. That's why we don't use this case. Next, let's do a equals 9. So if a equals 9, there are more ways to form the number 9 by adding certain values. So we have 1 plus 8. Let me do this way. 1 plus 8 equals 9. 2 plus 7. 3 plus 6. 4 plus 5. Okay, and also we have single value 9. So there are 5 ways to form 9. Okay, and we cannot use 3 sticks to form 9. Of course, we can add 3 values to be 9, but for the same reason, if we do that, we don't have enough 9s. So here we only have these 5 ways to do this, but to form a square, we only need 4 sides. So here we have 5, choose 4 equals 5 cases. Okay, that's for 9. Okay, let's go to 10. If A equals 10, we still have following values. Okay, 1 plus 9 equals 10, 2 plus 8 equals 10, 3 plus 7, 4 plus 6, and just 10 itself. Okay. Okay, and we have a number that's not used, which is 5 here. So here we have, if the side has at most 2 sticks, we have this 5 ways. Okay. So here we have 5 choose 4 equals 5 cases. But it's possible for us to use 3 sticks for certain size. In this case, if we use 5 and we break 2 sides and to form a new side. So for example, we have following. If I use 2 plus 3 plus 5, that means I break 2 previous sides and add this 5 into a new. So 2 plus 3 plus 5. This is one side equals 10. And I keep 1 plus 9. And I keep 4 plus 6 because the other one already broken. And then we still use 10. So this is a new way to form a square of side length 10. And there's another way to form this side length that's 1 plus 4 plus 5. So this corresponds to breaking other 2 sides. And we keep 2 and 8, 3 and 7, and still we have this 10. So we have 2 more cases. So totally if side length equal to, okay, equals 10, we have 5 plus 1 plus 1 equal to 7 cases. We have 7 cases. Okay, that's for A equals 10. Now A equals 11. For A equals 11, we have 5 pairs of sticks to get 11. See, 1 plus 10, 2 plus 9, 3 plus 8, 4 plus 7, 5 plus 6. So we just have these 5 pairs, and then we just choose 4 of them to form a square. So we have 5. Okay, let me use it right. 5 choose 4 equals 5 cases. Okay, equals 5 cases. Next, let's do A equals 12. Equal 12. So if A equals 12, okay, That means the parameter is 12 times 4, which is 48. Now the total sum of these 10 sticks is 55. So 55 minus 48 equal to 7. In other words, we don't use those sticks for certain sticks. These sticks add up to 7. We remove these sticks and they keep this remaining stick to form a square. And here the side length is 12. So 12 has to be a sum of at least 2 sticks. Okay. So we have at least 8 sticks. At least 8 sticks are used. So totally we have 10 sticks. So we remove 1 stick or 2 sticks. Okay, we remove 1 or 2 sticks. Now let's list these cases. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these sticks removed add up to 7. There are several ways to remove this. So first, we can simply remove 7 because that's equal to 7, and we keep all other sticks. This is possible because 2 plus 10 equals 12, 3 plus 9 equals 12, and 4 plus 8 equals 12, and the remaining 3 sticks, 1, 5, 6, add up to 12. So here we have 1 square. Okay, we have 1 square. There are other ways to remove sticks up to sum up to 7. So 7 equals 1 plus 6. So we can remove 1 and 6. And use the rest of sticks to form the square. Okay. For example, 2 plus 10. Okay, 10 has to be grouped with 2. Okay, that's the only way for 10 to add a number to be equal to be 12. Okay, that's the only way. So and 3 has to be with 9, and 4 is with 8, and 5 is with 7. So this contribute another square. And basically that's all for the side equals 12. But let me discuss why other cases are not possible. So seven could be equal to 2 plus 5. So it's okay if we just remove 2 and 5. And let's try to prove that the rest sticks cannot be used to form a square. For example, the reason is here. The number 10 cannot add a certain number to 10, so it equals 12, because we already removed 2. So this case is impossible. Okay. And also we can remove 3 and 4, okay, because that adds to 7. But here 10 has to be grouped with 2. That's the only way for 10 to add some number and equal to 12. And then we consider 9. 9 has to add 3 to get 12. But there's no way for 9 to add some number. We only have 1, 5, 6. There's no way to add number to 9 to get 12. So this is also invalid. And that's all because we remove 1 stick or 2 sticks. And we discussed all cases. For 12, we have 2 cases. So 2 cases. Now let's discuss the last case. The side length equals 13. A equals 13. If A equals 13, let's see what's the stick that's removed or sticks that's removed. So the parameter is 13 times 4, which is 52. And the total value is 55 minus 52, this equals 3. So we remove one stick or two sticks that add up to 3. So there are two ways to remove the sticks. One is just to remove 3, because that's 3, okay? And let's see if we can use the rest 9 sticks to form a square. Yes, it's possible, because we can use 4 plus 9 to be 13, 5 plus 8 to be 13, 6 plus 7 to be 13, and the 1 plus 2 plus 10 goes to 13. This gives us one this square friendly set. This forms a square. Okay. And then there's another way to remove sticks. We can just remove 1 and 2. Because 1 plus 2 equals 3. And then let's see if the rest stick can be used to form a square. And it is possible. 3 plus 10. 3 plus 10 equals 13. 4 plus 9 equals 13. 5 plus 8 and 6 plus 7. So we have another square-friendly set. So for a equals 13, we have two cases. Right, now let's add up all these numbers. Okay. So the total number equals A equals 7 is 1, A equals 8 is 1, A equals 9, 5, A equals 10, we have 7, 11, we have 5, 12, we have 2, 13, we have 2. So totally we have 23. So the answer is 23. Okay, let's do problem 20, the last one. It's a cubic equation. So we need to find the sum of these 3 roots. And these 3 roots are all positive integer roots. First, we note that one is the root. 1 is a root. Okay, you can plug in and check, it's just root. This is easy to see. So that means this polynomial, 5x cubed minus 5p plus 1 x squared plus 71p minus 1 x plus 1 minus 66p. This polynomial has the factor x minus 1. So we can use long division and factor this into x minus 1 times 5x squared minus 5px plus 66p minus 1. Okay. All right, we can assume 3 roots are, okay, we already have 1 root, so 1. And the other 2 roots, let me call it u and a v. Okay, we can just make it ordering. Suppose u is less equal to v, and 1 is, of course, the minimum root. So let's assume 1 less equal to u less equal to v. Okay, we make this ordering. And so u and v are roots of this quadratic equation. X squared minus 5px plus 6p minus 1 equal to 0. And then we can use Vieta's formula. Implies that u plus v equals 5p over 5. Okay, so 5p over 5, which is just p. And u times v equals 66p minus 1 over 5. Right? And we note that we can eliminate one variable. For example, right here we see that phi times u times v is 66p minus 1, and then p equals u plus v. So this is 66 u plus v minus 1. So from here, we can use one variable, one root to express the other root. So we use u to express v. So v equals 66 u minus 1 divided by phi u minus 66. Remember, v is a positive integer. We know that its numerator has to be positive because u is a positive integer. But so we require phi u minus 66 to be a positive integer. So this is larger equal to 1. So that means u is larger equal to 67 divided by 5. So this means that u is larger equal to 14. Because this number is already larger than 13. Okay, u is larger equal to 14. And also we require v to be integer. That means phi u minus 66 divides 66u minus 1. This is also important. So we notice that u cannot be a multiple of 2 or a multiple of 3. U cannot be divisible by 2, and u cannot be divisible by 3. That's okay. Let me explain why. If u is a multiple of 2, so actually, if u is a multiple of 2, we have that phi u minus 66 is even, and 66u minus 1 is odd. This implies 66u minus 1 phi u minus 66 is not integer. It's not integer, so it's not satisfied. And next, if 3 divides u, we can use similar reason. Okay, first we know that phi u minus 66 is a multiple of 3. So 3 divides this number. On the other hand, 66u minus 1 does not have multiple 3. So we know that this is not integer. Okay, that's why u cannot be a multiple of 2 or a multiple of 3. So u is larger equal to 14. So u cannot be 14, cannot be 15, cannot be 16. That means u is larger equal to 17. Right. On the other hand, we can find a upper bound for the possible value of u because u is less equal to v. So v equals 66u minus 1 over phi u minus 66. V is larger equal to u. From here, we can get an inequality for u. Phi u squared minus 132 u plus 1 less equal to 0. And from here, we can find the bound for u. So u is less equal to 132 plus root 132 squared minus 20 over 10. This number is less than 132 over 5. Okay, so this is like 26.4. Okay, so u is less than 26.4. So that means u is less equal to 26. But of course, U cannot be 26 because it cannot be even number. U is not divisible by 2, not divisible by 3, implies U is in the set 17. It cannot be 18, so maybe 19. 20 is not used. Okay, 20 is not possible. 21 is not possible. And 22 is even not possible. So 23. 24 not possible because it's even and multiple of 3. And 25 maybe, and it cannot be 26. So U can only be these numbers, 17, 19, 23, and 25. And we can double check these numbers. If U equals 17, then you can plug in and solve V equals 59. So this works. If U equals 19, 23, or 25, we can see that V is not an integer. Okay, so we only have one case. U equals, so the 3 roots are 1, 17, and 59, and their sum equals 77. So the answer is 77. All right, so this is the end of the solution video. Thank you for watching.